Point-slope form is a really useful form of a linear function when we are given information about a line and we want to write an equation. So if we want to write an equation in slope-intercept form and we're given two ordered pairs, like 3, -4 and 5, 2, we can use point-slope form to get to slope-intercept. Here are the ordered pairs. When we have two ordered pairs, we can always find the slope of the line that passes through them. So we'll start by labeling the ordered pairs x1, y1, x2, y2. Once we have those labeled, we can then go back to the trusty slope formula, m equals y2 minus y1 over x2 minus x1. Pull the values out of the ordered pairs, y2 and y1, 2 minus -4 over 5 minus 3. Do the arithmetic, simplify the fraction, and that gives us the slope. 6 over 2 simplifies to 3, and we have a slope m equals 3. Point-slope form, if you remember, uses a point and a slope. That's why it's called point-slope form. We will start with y minus y1 equals m times x minus x1. That is the format for this equation. We know m equals 3, so we will use that in the equation, and we can also use the x and y values from either of the ordered pairs. So if we use the first ordered pair, we have y minus -4, which becomes y plus 4, equals 3 times x minus 3. What's happening now, to simplify this and convert it into slope-intercept form, we are distributing on the right side of the equation, getting 3x minus 9, and then subtracting 4 from both sides to give us y equals 3x minus 13. That is the slope-intercept form of the equation that contains these 2 points. So y equals 3x minus 13. Let's check to see if that actually works. So we're going to take the ordered pair, put it in the equation, and make sure that it actually works out. -4 equals 3 times 3 minus 13. So -4 equals 9 minus 13, -4 equals -4. That's a check. That works. Let's use the other ordered pair. We plug in the 2 for y and the 5 for x. So 2 equals 3 times 5 minus 13. 2 equals 15 minus 13. 2 equals 2. Check. That's how we know that those 2 points are on the line that is described by this equation in slope-intercept form. Let's try another example. Let's try an example with 2 different ordered pairs. Let's try -2, -7 and 2, -5. Once again, we want to get to slope-intercept, but we're going to use point-slope in the middle to get there. We start by labeling the ordered pairs, so we're going to have our x1, y1, and our x2, y2. Remember, we're doing this because we'll be using the slope formula, m equals y2 minus y1 over x2 minus x1. A lot of numbers and letters in there. So our y2 value minus the y1 value, -5 minus -7. x2 minus x1, 2 minus -2. A lot of negatives there. It's nice to take an extra step to deal with the double negatives and write it as addition. So -5 plus 7, 2 plus 2. -5 plus 7 is 2, 2 plus 2 is 4. 2 over 4 simplifies to 1/2. m equals 1/2. That's our slope. Now that we know the slope, we can use point-slope form because we already have the ordered pair for a point. We use a slope. We write the equation. So y minus -7 becomes y plus 7 equals 1/2, which is m, the slope, times x minus -2, which is x plus 2. Simplify the right side by using the distributive property. Y plus 7 equals 1/2 x plus 1. Subtract 7 from both sides of the equation, giving us y equals 1/2 x minus 6. Let's see, we had 2 ordered pairs. Let's try the other one, see if it works also. So we do y plus 5 equals 1/2 times x minus 2, using the x and y values from that other ordered pair. Same process. Y plus 5 equals 1/2 x minus 1, using the distributive property. Subtract 5 from both sides. Y equals 1/2 x minus 6. Look, I get the same equation using either ordered pair. I should. It's the same line. Both those points are on that same line. Now let's check. So we start with the equation we came up with, y equals 1/2 x minus 6. We're going to plug in the ordered pair, -7, -2. We'll see what happens. Excuse me, -2, -7. So -7 equals -1/2 times -2 minus 6. -7 equals -1 minus 6. -7 equals -7. Good. Other one. -5 equals 1/2 times 2 minus 6. -5 equals 1/2 times 2 is 1 minus 6. So -5 equals 1 minus 6. -5 equals -5. Did I do that right? Yeah, -5 equals -5. So it checks out with the other ordered pair as well. It's always a good idea to use the ordered pairs you were given to make sure that your final equation is correct. So now we have an equation in slope-intercept form for the line that contains the 2 points we were given.